A wire has certain electrical resistance. The diameter and length of the wire may be changed. Which pair of changes must cause the resistance of the wire to increase? So here in O-level physics, we study that the resistance of the resistor depends on several factors, and one of them were diameter, first of all length. You can say the more the length, the more the resistance, like this. Then there was another one, the area of cross section, and that was inversely proportional. So the more the area of cross section, the less the resistance. So diameter in that case would be same, because if the diameter is more, area of cross section would be more, but length is independent of area of cross section. Okay, so area of cross section is basically the thickness, and length is how long the wire is. So you can have a wire with same area of cross section but different lengths. So length in case of a wire does not affect the area of cross section. So what do we need to do anyway? We need the resistance to increase. So in order to increase the resistance, length should increase and the area of cross section should decrease. So length increases and area of cross section or the diameter should decrease. So it should be the option B. Right. Over to the next one. A flexible electric cable consists of a central conductor and the outer insulation. Which pair of material is suitable for the cable? So the central part has to be the conductor and the outer part has to be an insulation. So if we take a look at, let's start off with the option A. We have copper, we have plastic. Yeah, fair enough. Lead, nope. Plastic, nope. Wood, no. Because lead, okay, you can say that the lead is a conductor of electricity, but the wood is not used as the insulator because the cable would not be stretchable. You would not be able to move the cable around easily. So the most compatible option is A. Alright, over to the next one. The diagram shows a battery connected to two resistors. Okay, then we can see in the diagram, 4 students separately measure the potential difference or EMF of the battery, the current in the resistor, and the potential difference across the resistor R. Their results are shown in the table below. Which row shows the values with their correct units? Alright, so it's kind of an easy one. So we have 3 things: EMF, current, and potential difference. What is the unit of EMF? And the unit of current? Amperes. And the unit of potential difference? Volts. So the potential difference, EMF, and current has to be in that order. So let's take a look at the option A and B. They are saying they are measuring the EMF in amperes, which is incorrect. EMF has to be in volts. So option A, B, out the window, not in consideration. How about the option D? EMF is being recorded in volts, current is being measured in amperes, potential difference is being measured in volts, and also you realize something, that the EMF of the battery is more than the potential difference, because whatever the EMF of the battery was, 3.0, let's say in that case 1.5 volt was dissipated across the resistor R, and the remaining would be dissipated across the other resistor. because the remaining voltage would be given by, to the second resistor. But the thing is, in A levels, we consider another thing as well, which is internal resistance of the battery. And some of the voltage is dropped, or some of the voltage is dissipated across the internal resistance of the battery as well. But for O levels, we don't have it, so let's proceed on. The table describes 4 different resistance wires. They are all made up of same metal. Which wire has the smallest resistance? Okay, so for the smallest resistance, the length has to be the smallest and the area of cross section or the diameter has to be the greatest. Length has to be the smallest, but area of cross section has to be largest. So length has to be the smallest, so for this one, what if we choose, let's say, okay, so we got a what we can do is we can use the ratios, because if I choose this one, first one, the length is small compared to 3 meters, but then the diameter has to be greatest, so length has to be smallest. Here we have the smallest length, and here we have the greatest area of cross section or the greatest diameter, B, because what we needed was, we needed smallest resistance, and in order to have the smallest resistance, you have to choose from the smallest length, so that spares us from the option C and D. But at the same time, we have to choose from the greatest diameter or the greatest area of cross section. Alright, question number 8. A student uses a length of a wire as a resistor. He makes a second resistor from the same material. To be certain of making a second resistor of high resistance, he should use a piece of wire that is, so he needs to increase the resistance. High resistance means he needs to increase the resistance. So he needs to, in order to increase the resistance, he needs to increase the length and decrease the diameter or the area of cross section, whatever you want to call that. Or he needs to decrease the thickness, means he needs to use a thinner wire. So we have to use a longer and thinner wire. So it has to be the option B. An electromagnet with soft iron core is connected to a battery and an open switch. The soft iron core is just above some small soft iron nails. Okay, the switch is now closed, left closed for a few seconds and then open. What do the soft iron nails do as the switch is closed, and what do they do when the switch is open? So as you close the switch, so something like this is going to happen. The switch is closed. That means the circuit that you have here is completed. So it will look something like this. Current can flow through the circuit, and the electromagnet, this thing would act like an electromagnet, and thereby the soft iron nails would be attracted. So as you close the switch, the soft iron nails would be attracted. They would jump upwards towards the magnet. So nails would jump up. So it can't be the option C or D. And as you close the switch, as you open the switch means now the circuit is off. So open the switch would look something like this. Now the current cannot flow through the circuit. The electromagnet would once again demagnetize because you're using soft iron. Soft iron works only as a temporary magnet. It is a soft magnetic material. It only works as a temporary magnet. Soon as you switch it off, the magnetic properties vanish. So straight away, the nails would fall down. So it would be the option A. The diagram shows a piece of metal resistance wire. Which wire made up of the same metal has smaller resistance? So these kind of questions are very repetitive. You get these kind of questions very plenty of times in your exam. So you need to decrease the resistance. So what we can do is we can not use a greater length. So this can't be the option. We can't use a greater length. What we can use is, if we don't have the option to reduce the length, and the only option is to go with the same length, so we can change the other factor. We can change the diameter in order to decrease the resistance. We can increase the diameter or the area of cross section. So wire of same length but with a larger diameter. So for question number 10, we have A is the right answer. Alright, question number 11, very easy one. Which diagram shows the pattern of magnetic field produced by a current carrying solenoid? So it is the last one, the option D. So in this one, you see the field lines only inside the solenoid are uniform. So I can write over here, field lines, and the circular magnetic field, the circular magnetic field lines are for a straight wire or a current carrying conductor. Alright, question number 12. A student has wires of different lengths and different diameters. The wires are all made of same metal. The student measures the resistance of one wire. Which wire has the greater resistance than the wire he measures? So the longer wire, but we don't have the option for the longer wire, so we'll be going with the same length, and then we can change the other factor, which is changing the diameter. And in order to increase the resistance, we need to lower the diameter. So for 12, D has to be the right answer. Over to the next one. Diagram 1 shows two thin uncharged strips of plastic. Diagram 1. The diagram 2 shows the same strips after they have been rubbed. Okay, this one is from static electricity. Let's skip it for a while. Then we have the next one. What is the unit of electromotive force, EMF? Amperes, that is the current, electric current. Newtons is the force. It can be any kind of force, magnetic, electric, electrostatic, any kind of force. Ohms is the resistance. And the last one, volt, is the unit of electromotive force. Which sample of copper wire has the greatest electrical resistance? So we need to choose from the higher lengths, the longer wires. So we need to choose from C and D. Now from C and D, they have same length, but the greater resistance would be for small diameter. So would be option C, because small diameter is just like a narrow road, and there would be the traffic would be so much congested, so the resistance in the traffic would be there would be a lot of resistance. So the same analogy can be used here. Then we have the next one. Which row gives the unit of electromotive force and the unit for potential difference, PD? Electromotive force, we have the word force in the name, but the unit is volts because it is a work done per unit charge, and the potential difference also has the same unit. What is the unit of electrical power? Amperes is for current, joules is for work done, volt is for EMF, watts is for power. Okay, 18. Some resistors are made using one type of wire. Two different lengths of wire are available. Each length is available in two different diameters. Which wire has the highest resistance? You see the same concept being repeated. Not the smaller length. Can't be C or D. Now the wire with greater length and the smaller diameter. Wire with the greater length and the smaller diameter. Okay, 4 students are each given an identical resistor, and asked to find its resistance. They measure the potential difference across the resistor and current to it. One student makes a mistake. Which row shows the result of the student that makes a mistake? We were having the identical resistors, so the resistances of all those resistors should be same. So what you can do is you can find the ratio of voltage to current. So do it for the first one. Like for the first one, what you can do is 1.2 divided by 0.5. It would be doubled, and that would be 2.4. Then do it for the second one, do it for the third one, do it for the fourth one. Whichever one of these is different would be the one that is the result of the student that makes a mistake, because the resistance has to be the same as the resistors were identical. Take electricity, we're skipping for a moment. Okay, 21. Once again, the same concept. You need the largest current. So in order to have the largest current, you need the smallest resistance. And in order to have the smallest resistance, you need the smallest length and the maximum diameter. So the smallest length would be 0.5, so we can skip C and D. And between A and B, we have to go with the largest diameter or the larger diameter. So smallest length and largest diameter, so would be B. Alright, so we gotta go with the largest length and the smallest diameter, so C is the right answer for this one. Okay, over to the next one. The circuit shown contains a battery, 6 ohm resistor, and 2 meters X and Y. 1 meter records current and the other one records potential difference, which shows possible values for the readings on the meters. So meter X is placed in series. You can see it is connected in line with the battery, and the meter Y is connected across. So the meter that is connected in series is the ammeter, and the meter that is connected across the appliance is voltmeter. So it has to be either option A or option C, because option B and D are measuring voltage across with the meter X, so this can't be the case. Now we gotta choose from option A and C. Now the thing is, the resistance of the resistor is 6 ohm, so we need to consider this thing as well, that resistance equals to the ratio of voltage to current. Now which one of these two options gives you the value of resistance as 6? So if I choose the option C, V equals to 2, current equals to 12, and that gives you 1 over 6. Resistance is not 1 over 6. If I choose the option A, voltage is 12, current is 2, you hit it on the calculator, or I mean, it should be obvious, you get 6 ohms. So A has to be the right answer. A battery is connected to two crocodile clips and a clamp and a lamp. There's a gap between the crocodile clips, okay? 4 cylinders WXYZ are made up of same metal but different dimensions. Means they can have different length and different thickness. The cylinders are connected in turn by the ends. Okay, anyway, what is the question? Which cylinder makes the lamp glow most brightly, and which cylinder makes the lamp glow least brightly? So the cylinder with the lowest resistance would enable the lamp to glow the brightest, because if you have lowest resistance, then it implies that more current can flow through the circuit and the glow would be brighter. So first of all, let's choose the cylinder which makes the lamp glow the brightest. So we gotta pick the lowest resistance. So for the lowest resistance, we need to choose between W and X because they have the small length, and among these two, between these two, we'll be going with the option X because it has more cross-sectional area or more thickness. Now for the least bright, we have to use or choose the cylinder with maximum resistance. So what's going to happen is, if there's a lot of resistance, the current passing through the circuit would decrease and thereby the glow would be reduced. So for the highest resistance, we gotta choose the maximum length, so it can be Y or Z, but we have to choose the lowest thickness. We have to choose lowest cross-sectional area as well, so it would be Y. So X for highest brightness and Y for lowest brightness. Does that make sense?
Yes, sir.
Okay.